Okay, so in this one, we're going to look at how different graphs are manipulated. So I'm just going to look at different functions and what happens to them when we change the function a little bit. So in this first one, we're looking at y equals f of x. Now it's a not normal straight line. But if we wanted to look at y equals f of x, and we're just going to add 2 to every value. So what would happen to that graph if we just added 2 to every value? The graph would suddenly move up 2, because that's all we're doing. We're adding 2 to every value of it. So that's with the 2 out the back here, and it would be that line. If we wanted to do something like y equals the absolute value of f of x, okay, the absolute value always is going to be positive, so the absolute value of f of x would look like this. This side's okay because it's positive already, but the absolute value of this is going to be a positive number, so that's what y equals the absolute value of x would look like in the yellow line. So this would be, this blue line is y equals f of x plus 2. We're just adding 2 to every value. And the yellow line is y equals the absolute value of f of x. Let's have a look at this, and we'll muck around with this a bit. This is y equals f of x. Let's just suppose this is y equals sum f of x. Instead of this, let's see what y equals f of x plus 2 would look like. Okay? So here, this is x equals 0. X equals 0, f of x is minus 3. So what this does is when x is minus 2 plus 2 already gets us to the 0. When x is 0, we're going to plus 2 to it. So it's already, everything's just happened a little bit quicker. So this graph is moving. So at x equals, at minus 2, you're already at x equals 0, because minus 2 plus 2 is 0. So y equals f of x plus 2 is going to look like this parabola. It should stay at the same point, but everything is just moved this way 2 units. So this point here, move this 2 units. This point here, move 2 units. Okay? So that's if it's inside like that. If we wanted again to look at y equals the absolute value of f of x, okay, and we'll do this in yellow again. Y equals absolute value. Here it comes down to there. Then it would bounce back up. And that yellow line would be y equals the absolute value of f of x. I'll find a different graph and we'll look at a few different things. Let's have a look at this graph. And again, let's look at a few things. Let's look at if this is y equals f of x. This is the graph y equals f of x. Let's look at what happens if it was y equals f of 2x. So again, what that means is everything's going to happen twice as quick. So we're going to squash this graph because everything's going to happen twice as quick. Instead of it crossing here at about 7.5, it's going to cross at about 4. Okay, so everything's going to happen twice as quick. 2 times 0 is still 0, so it's still going to go through there. But this graph is going to be squished up there. So here it is at 10. That should be right on 5. And you can see that I'm a little bit off, but 2 times 5 gives us 10. So having the 2x here squishes it. So this graph would look like this. This side wouldn't change too much at all. You wouldn't be able to see anything there. If we wanted again, if we wanted the absolute value, it would pop up this way. But let's suppose we change it a little bit for this graph, and instead of the absolute value outside, if we wanted y equals f, and it's going to be the absolute value of x. So the absolute value sign in there. So basically what happens here is all these numbers we don't care about. We don't care about what happens at x equals -2, because when we put -2 in here, what's the absolute value of -2? 2. So this is y equals f of x. And y equals f of the absolute value of x. Instead of -2 being out here, -2 is going to be the same as 2, so it's going to go back up. -15, when we put -15 in here, the absolute value of -15 is 15. It's going to be off the page already. So it's slightly different depending where you have the absolute value signs. Again, this one, we've got y equals f of x. Let's call this y equals f of x. Let's graph y equals f of a half x. So what that means is, if we put 10 in here, a half of 10 is 5. So at x equals 10, it's going to be the same as this graph at x equals 5. So when it was 2x, everything got squished. When it's a half x, everything's going to get stretched out. At x equals 4, half of 4 is 2, so it's going to be down there. So this parabola, half of 0 is still 0, so that's not going to change anything. And the parabola is going to be stretched out. This is at about 8, so it should be off the page at about 16. A half of 16 gives us the 8. And the same on this side. So that would be y equals a half x. Y equals f of a half x. So there's just some of those manipulations that Alan was doing at the end of the lecture. Hope that's made it a little bit clearer. Thanks. And I will figure out how to stop it in a little while.